So here you've got your 12Z runs of models. 12Z, that's at 6 a.m. So the model is run at 6 a.m. And we take a look at it and we try to forecast the weather using that run of the model. Here are the 6 p.m. runs of those models. There's even 1 a.m. or midnight and noon run of those models. So some of these models are run 4 times a day. So we've got a lot of data that we can look at from a lot of different sources to come up with a forecast. Here's a look at something I was looking at this morning. Our GFS model, 12Z, you see 12Z right there, and here it is, all of them. So this is going to take us out, this takes us out 7 days, 180 hours, 7 days. Here you have your jet stream. Here you have your highs and your lows. Yes. Here you have your precipitation. Purple's light, green, moderate. You get up to the yellows and reds, that's the really heavy rain or snow or ice. And then over here, this is just kind of like showing you about where the clouds are. The green, that's where you're going to have clouds. Orange, that's dry. So, we take a look at this. Where's Arkansas in here? Well, right here. Here's Arkansas. Right? So it looks kind of small. But we're looking at the whole United States. And in order to forecast the weather here, we have to look at the whole United States. We can't just focus in on Arkansas. We have to look at everything. So we have to look at the whole United States and Canada, and I like to even look out even further. But here we go. We can actually take this model through time. So this is 6 hours. This is by noon today. And this is by 6 p.m. And we can see that a little trough is coming through right here. You see that low? Little trough is coming through, and so you might see a few clouds later today, but it's a pretty weak system. You can pick it up on the jet stream. You can see this trough figure right there. Yeah. And here's us, northwest Arkansas. But it's a weak system, so it's not going to bring any rain. It just might bring a few clouds.
Okay, now it sounds just like you're on the air.
Yeah.
It does, doesn't it?
I can't stop. I can't turn that off. I just can't. I'm sorry. When you start talking about the weather, there's nothing better for me.
So you're
you
kind of
see,
like...
We're at 120 hours at this point. This is 5 days from now. Right? So this is Sunday morning, and here's a more significant system coming in. And you can see all the rain that this model is showing. Sorry, I got my cough drop in. Only way I can talk right now. But here we are by Saturday evening, and what's this? Green. So we've got showers and storms moving in, and maybe even a strong to severe storm on Saturday. So it could be a wet Saturday.
Me?
Not on Saturday. Not on Saturday. But look at this too. This is interesting. This is Friday afternoon. Look at all the warm air pushing north right here. A lot of warm air coming in on Friday. Thursday too. So it's going to be a warm week.
Cool.
All right. Then we take it through Saturday, and then what about Sunday? Will Sunday be a little better? Well, I don't know. Here, take a look. Here's Sunday. Here's Sunday. Do we have any rain over us?
No.
No, it's dry. So it'll be drier, but look at all that cold air that's come down. You can see all that cold air that's come down. So it'll be kind of chilly on front. Yeah, exactly. And you can pick out the cold front right here. So it'll be colder on Sunday, but at least it'll be dry, as it appears right now. There's a slight chance of rain on Sunday, but it looks better than Saturday, which, especially Saturday evening, could be very wet. Go out even further. Go out into 7 days. Look at this. Here's another one of these cold fronts coming through, dropping snow in North Dakota and Minnesota. And then, as it pulls through here, we get another shot of cold air, and we start noticing a change in the pattern. This warm pattern that we've had throughout the entire fall, all of November, and much of the beginning of December, we're going to see near record highs later this week. We start to see a change in that pattern. Maybe a colder pattern working its way in. Maybe not, but there are signs that that could occur. It may not happen, because remember, these models, they're not perfect. They're not, obviously, right?
No.
My forecast isn't perfect, and these models are even less perfect, if that's even possible, right? So, you got to take it with a grain of salt. And you got to look at other models. So here's one model that I'm looking at. Well, I kind of want to look at another model. Really get a good idea for what's going on here. Here's the Euro model. It looks similar, right? But it's not the same. They use slightly different parameters. More data actually goes into the European model because it's got more computing power. Not much in the GFS, but a little bit more. So you would think, well, if it's a stronger computer, then this is surely going to be the more accurate model. It's not. Not all the time. Sometimes it is, but not all the time. So you have to look at this model, you have to look at that model, and all kinds of models. And then you don't just take what that specific model is saying and say, that's the forecast. You have to combine them and create almost a mental model in a sense. You come up with your own forecast. You blend all these models into your own forecast. And it takes years of looking at these models to really start to get a good feel and understanding for doing this. It takes time. It takes a lot of time. But once you get there, you start to come up with some pretty decent forecasts and you get it right once in a while. Every once in a while. Right? Okay, hey, I want to talk a little bit about severe weather safety. I think you guys probably pretty much know a lot about staying safe during severe weather. All right? But we're going to do a recap today, okay?
Okay.
Take a look at this. Now, I'm going to show you some pictures. They're going to look a little bit crazy, but I want you to remember this is a very unusual situation. This is Joplin, Missouri, not too far north of here, before a tornado that hit there a couple years ago.
Yeah,
I'm sure most of you
Yeah, I
heard of this
remember
tornado,
that.
right?
Yeah.
Well,
Yeah, I remember
the
that.
tornado did come right through here. Now, this is an EF5 tornado. This is one of the strongest tornadoes ever recorded. One of the strongest tornadoes ever recorded. So, is this the kind of thing that's likely to happen many times?
Yes.
No, it almost never happens. Almost never happens. But really strong tornadoes can do a lot of damage, right? So take a look. This is the area before the tornado, same area after the tornado.
Oh
Look at all the
goodness.
damage, right? Right. So this is the worst case scenario. Is this kind of thing going to happen very often?
No.
It's not. But does that mean we shouldn't be prepared?
Yeah, when it should be.
We need to
Yeah.
We want to be prepared because this kind of thing, while it's unlikely, can happen. Now, is this going to happen to us? Probably not. Almost certainly not. But some other version of this. So a weaker tornado could certainly move through. So we want to be prepared no matter what happens. Here's another picture. This is an apartment complex. Now I want to show you this for a very specific reason. All right. How many of you live in apartments or houses on the second floor? On the second floor. Anyone? 1, 2, 3. A few people live on the second floor. Now, if you live on the second floor and a tornado is coming, is that where you want to be? You want to be on the second floor? No. You want to be as low as you can get. Here's why. Take a look what happens with these apartments after the Joplin tornado. Right?
Wow.
Now, what do we notice here? We notice that the rooftops are gone off of these homes. So, if you were on this exactly. So if you were on the second floor,
Bye-bye.
it'd be bad. But if you're on the first floor, you've got a much better chance of surviving this storm. Even an EF5, the strongest of all tornadoes. All right, you want to be on that first floor as low as you can get.
There's also a tornado that's 3.7 meters long or wide.
We'll get to that in a bit. Take a look at this right here. This is a hospital in Joplin.
Yes.
Yep, I
Now,
remember that.
I
Yes.
just told you that you want to be on the lowest floor possible. But there are exceptions to every rule. Now, this hospital and most hospitals are kind of an exception. Any really well-built structure, well-built hotels, well-built hospitals, really well-built, sturdy, reinforced structures, really strong structures, like this hospital, and a lot of hospitals, even an EF5 tornado, while this hospital didn't necessarily take a direct hit, even this hospital, you notice it didn't get ripped in half. It's got all its floors still, all right? So what's
It's just
most
the
important, exactly, what's most important about, if you're in this hospital, do you think it's more important to get to the first floor, or do you think it's more important just to get into an interior room?
I think
An interior room, right?
I think it'll be a lot better if you're in the hallway.
Exactly, or an interior room, like a closet even.
Or a
You just want to
bathroom.
be away from the windows, because you see the windows were all blown out, right?
See, if
So
you
every
get here
situation
before.
is not the same. You have to use your common sense. That's what really matters, using your common sense. Stopping, thinking, and just kind of calming down for a second. What should I do? What makes the most sense here? Usually it's getting to that first floor, but there are exceptions. What does a tornado look like on radar?
The red.
The hook, right?
Uh-huh.
The hook.
You've heard me talk about the hook, right? We'll answer questions
It's
at
a
the
round
end.
circle.
Right, well, we'll answer questions and we'll talk at the end. But
Yeah.
just, I mean, if you have the answer, just tell me.
It's a round circle.
Well, not necessarily. Take a look at this. It's kind of like a round circle. What it really is it's a hook right here, right?
Oh,
So
yeah.
now this is the thunderstorm. It's not the tornado. This is base reflectivity. So right here, all the reds and purples, that's where the heavy rain is. That's where the hail is. That's where the really strong winds
Yeah,
are.
if it has
Oftentimes
gray in it,
before
then
the-
that's the tornado.
We'll get in a second. Oftentimes, the forward flanking downdraft is going to be coming out of this part of the storm right here, right? That's the circle you're talking about. The heavy rain and hail. Now, here at the base of the hook, that's where the tornado is. And interestingly enough, with the Joplin tornado, it was such a big, strong tornado that our radar actually picked up the tornado itself. Now, at this point, because it's so far away from the radar, not that far, but far enough, yeah, I don't know if we're necessarily picking up the tornado or perhaps the mesocyclone with the storm, which is something different. But the radar is picking up very well in this tornado, and you can see the radar can also estimate the wind speed and direction, a Doppler radar, using the Doppler effect. So the radar can show us where the winds are moving away from the radar and where they're moving toward. The blue is toward, the yellow and red is away, and when they're butted up so close like that, that's where we've got rotation, right? And so we can find the rotation using our Doppler radar too. Very useful tool for us when we're covering severe weather. When you see me up there and I'm covering severe weather, I'm looking for something very much like that.
You know,
And hoping that we don't find it. All right, let's take a look here. Here's another profile of a